Welcome to a short tutorial series on Progress Chef. Chef is a set of tools to help you manage your infrastructure. In the first part, we'll explain the different parts of Chef and how they work together. Afterwards, we'll go over our use case for Chef and how we've implemented it. In the rest of the tutorial, we'll show you how we've done this and how you can do it too. Along the way, you will learn about the different parts of Chef and how to work with them. So at the end of this tutorial series, I hope you understand the basics of the Chef ecosystem and how to work with the tools. Before we begin, let me explain our current situation. We are a Minecraft server hosting company and we run our servers on our on-premise hardware. These servers are almost at their maximum capacity, and for further expansions we are looking into moving the new users into the cloud. Using infrastructure as a service, we can mimic our on-premise servers in the cloud. However, while we're scaling up, we need to keep a clear overview of all of our servers, on-premise and in the cloud. To achieve this, we'll be using Progress Chef. In the Chef ecosystem, we use Chef Infra to manage our different Minecraft servers. On our servers, we'll have to install the Chef Infra client, which are connected and report back to the main Chef Infra server. This main Infra server reports them back to the Automate dashboard that gives us insight in the status of all of our servers. Then on top of that, we'll use the Chef Cookbooks to take care of the installation of new Minecraft servers. Lastly, we'll use the Chef InSpec to check for vulnerabilities on our servers and if the Minecraft server is actually running. This all will be managed from our Chef workstation using the Chef CLI tools. Now let's go into a more in-depth view into the Chef ecosystem. There are a few components to the Chef ecosystem. We'll go over them here. First off, we have the Automate server. This is the main component where everything will come together. It has a web server with a dashboard where you can view the current status of your infrastructure. Next to that, on the right, we have the Chef Infra server, which is directly managing all the nodes. Nodes are the servers that are connected to the infrastructure. This could either be virtual machines or physical on-premise servers. Over on the left is your own PC. This is called the workstation. On the workstation, there are a lot of CLI tools installed that help you manage the rest of your infrastructure. We won't cover all of them here, but we'll go into them later into the tutorial series. Let's start by installing Chef Automate and the Infra server. For this, we need to execute some commands on that server where we're going to install it. I'll be using SSH to do this remotely. Once we're in the server, we first need to set the hostname correctly, so make sure you have a domain name that points to this server's IP address. Execute sudo hostnamectl set hostname automate. Your domain name. In this case, we'll be using automate.ctmtutorials.nl. And to check if it's set correctly, we can use hostname-f to check if it indeed was set correctly. Afterwards, we can continue with downloading the Automate installer. After we download it, it should have this file right here. We can use this file by installing it using this command. Using that downloaded file, using the deploy command, we're going to deploy two products called Automate and the Infra server. I will agree to the terms, conditions, and we'll start doing some pre-flight checks, seeing if all the environment variables and the things on the server are set correctly. We see that two things failed here. And it will also give me the commands I need to do to correct these errors. So I can copy these and say sudo and do that, which sets it to 2000, and the other thing, copy. So now I'm going to execute the deploy command again, and this time, after accepting the terms, the pre-flight checks should be successful, and now it will be installing the Chef Automate server. After Chef Automate has been successfully installed along with the Infra server, we will use the command tools named Chef Server CTL to connect to the Infra server that is running on this server right now to create a new user called Automate. Automate, first name, last name, username, all automate to keep it easy. For the email, we used our domain email, and for the password, it has to be, we'll be using password 123 exclamation mark to keep it secure. Choose something else, and we use -- file name to put in the private key into this file. After executing this, we do ls, we'll see that the automate.pem has generated. Also, we can see the automate credentials.toml, which will include the authentication for the dashboard. Afterwards, we need to create an organization. This organization will be associated with the user, and we can use this organization to upload our cookbooks and other things later on in the tutorial. We'll use the serverctl command again to create the organization called Infra. This is where our infrastructure will be managed. Call it Infra server as a name, and we associate it with the user automate. The file name, again, for the private key will be infra.validator.pem. We execute this, and after taking a look in our directory, our infra.validator.pem has been created. Now we can open up a browser, and if we browse to our domain name that I filled in, take a look at our domain name here. You can also click on the link here to access the UI. It will warn us about a potential security risk. I'm going ahead and click Advanced and accept the risk. This is because this is a self-signed certificate. The Chef Automate server comes with its own CA certificate authority. This makes it make its own certificates and sign its own keys. The browser doesn't really like that, but you can also put it behind a reverse proxy, but that is out of the scope of this tutorial. As I want to sign in, I need a username and password. As I just said, it will be located in this credentials.toml. We need to use sudo to access this file. I'm going to use cat automate credentials.toml to see that the username is admin and the password is this string here. I will copy this, go to the dashboard, use the username admin, and the password I paste it in here. We can sign in. I'll save the password for now. Now we can register our 30-day trial. Make sure that if you're going to use this for production, you get a license. For now, I will use admin for this test environment. I agree to the terms and I register. Now here we're on the dashboard. I'll make it full screen. We'll go over the dashboard real quick. The dashboard here shows all the events that happened. We created the user, we created the organization, and we created the group as well. This is done when you create the organization, so this is all good. If you see this here, normal activity. In the application tab, you can use the Chef Habitat to manage your applications. This will not be used inside this tutorial. And for the infrastructure tab, here we'll see our nodes once we've connected them later on. And for the compliance is where we can schedule our jobs and see if all our infrastructure is tested and what the results were of those tests. Head on over to your browser and open the URL, that is the domain name of your Chef server. Once you entered the Chef Infra server, head on over to the Infrastructure tab. Here, click on Infra Servers. We will need to add the Infra server that we just created in the command line. We can add the name, which was Infra, and we need to fully qualify the main name. Since we host the Infra server on the same server as the Automate dashboard, we can take the URL of the Automate dashboard and paste it into the fully qualified domain name. After that's been added, click on the newly created Infra server and add the organization that we added. The organization was also named Infra, and the admin user was the associated user, was named Automate. We need the private key from the Automate user, which we can obtain by going back to the terminal and typing sudo cat automate.pem. Make sure you copy the whole key, copy and paste it into this field. Now adding the organization, it will appear here, and after clicking it you can see everything is here. Later on we'll be able to add clients, the nodes, and everything will show up here. That's it for part 1, and in the next part we will be adding a node and seeing it show up here. Welcome to the next part of our short tutorial series on Progress Chef. In this section, we'll demonstrate how to connect nodes to the Chef Automate server. To prepare your nodes to run the Chef Infra client needed to communicate with the Chef Infra server, Knife provides a handy command line tool to bootstrap nodes you specify. This process is automatic and downloads and installs the Chef Infra client on the node, after which an initial Chef Infra client run is performed. We'll get into this later when we work with our cookbooks and recipes. This will configure the node and register it to the Chef Infra server, and it will show up on the Automate dashboard. Before we can start setting up the node and bootstrapping it using the Knife command line tool, we need to install it by installing the Chef workstation. After we've installed the dep file, it will give us access to a couple of command line tools, of which Knife is one of them. After Knife is installed, run knife configure init-config to bootstrap the configuration. It will prompt a few questions, in the first one being the Automate server URL. Paste in your own Automate server URL, appended by organizations / the name of the organizations that you created in the last chapter. For us, that will be automate.ctm-tutorials.nl/organizations/infra. Afterwards, enter the username of the organization owner that has been created in the last section. For us, this was Automate. In order to give Knife access to our Automate server, we will need to have the private key copied over from the Automate server to our workstation. For this, I will open this tab where I've SSH'd into my Automate server. Here, I'll look for the file automate.pem, which is the username of the administrator.pem, which I will print out on the screen so I can copy it and paste it into the other file on the workstation. After this file has been saved, run knife SSL fetch in order to fetch the certificates from the Automate server. We can ignore the warning here and run knife SSL check in order to see if the files have been verified successfully. In order to actually bootstrap the server, we can now use knife with the bootstrap command, appended with the SSH combination with username at IP address, -n for the name of the node, which the name will show up in the dashboard, and --sudo in order to make the installation work. We need to install a couple things on system level. This is why sudo is necessary here. Otherwise this installation will fail, saying it doesn't have enough permissions. After filling out the password, Knife will take care of the bootstrapping process and tell you when it's done. After this finishes, head over to your browser and go over to your Automate dashboard. On the dashboard, head over to the Infrastructure tab, and if everything went well, you see that you have a total of 1 node. Now we have successfully connected our first node to the Automate dashboard. In the next section, we'll talk about cookbooks and how you can install things automatically on this node. Welcome to the next part of our short tutorial series on Chef. In this section, we'll demonstrate how to configure a node automatically using Cookbooks, Chef's implementation of infrastructure as code. Chef uses a concept of cookbooks with recipes, Just like in real life, a cookbook can have multiple recipes. All recipes are written in the programming language Ruby, and they use a predefined set of functions provided by Chef to do basic tasks like creating a file or deleting a file, creating a directory, downloading something, etc. This is because some recipes can then run on Windows, Linux and Mac because those predefined set of functions are cross-platform compatible. These recipes can be assigned to nodes. On the node, the Chef Infra client that we installed in the last section using the bootstrap command is responsible for running the recipes. If nothing changed on the system or in the recipes, the Chef Infra client will not change anything. This makes it easy to make sure that your infrastructure is always in the desired state. Chef infrastructure as code is managed in a repository called the Chef repository. This includes the Cookbooks and InSpec profiles that we'll be creating in this section and in the next. To generate a repository, use chef generate repo and the name of your repository. For now, we'll call it chef-repo. In the chef repository, there will be a lot of files generated, but we'll be focusing on Cookbooks directory. To create your cookbook, navigate to the Cookbooks directory and use the command chef generate cookbook and the name of the cookbook, in which case we'll call it Minecraft. You can write cookbooks yourself, but most of the time you can use the Chef supermarket to avoid rewriting basic installations. To manage these other cookbooks from the supermarket, we can create a Burks file. In this file, we describe the external sources and dependencies needed to run this cookbook. The Burks file is used by another command line tool from Chef called Bookshelves. The CLI for this is called Burks. Minecraft is built using Java. For our infrastructure, we need to make sure all our servers are running Java 17. To do this, we'll add the following to the Burks file. To install the cookbooks and dependencies we specified in the Burks file, we need to run Burks install. Make sure you do this inside the Cookbooks directory where we place the Burks file, otherwise it won't work. Now that our dependencies have been downloaded into the cache, we can push them straight to our Automate server. However, once you are writing your own recipes, it is useful to be able to test them locally. To do this, we need to move the dependencies from the cache into our Cookbooks directory. To do this, we can use Burks vendor and then .. to indicate where they need to be. It is time to create our first recipe. In here, we'll write a script that installs a Minecraft server. However, you can automate any manual installation work here. Let's create a file under our Minecraft cookbook under the recipes folder. In here, put the following content for now. Now we'll go over how to test this code locally before sending it to the nodes. Create a file called solo.rb and put it into the root of the repository. Inside this file, add the following content. We need to make sure that the cache folder exists, otherwise Chef will throw an error. So make sure you make the directory. To run the recipe locally, use the following command: sudo chef-solo -c for configuration and -o to override which recipe it needs to run. First, there's the name of the cookbook, followed by 2 colons, and then the name of the recipe you want to run in that cookbook. We can see if it worked by looking at our home directory and seeing if the test file was created and with the correct contents. Now let's update the contents of our recipe to actually install the Minecraft server. First, we'll create a new user on the system. This can be useful for security since it has less permission than a root user. We can do this by using the user keyword from the predefined set of keywords that Chef gives us, followed by the name of the user and followed by the do keyword. Afterwards, we can specify a few parameters. Next up, we'll create a home directory for this new user using the directory keyword from Chef. Note that all these keywords have implementations for every operating system, so this script up until now is cross-platform compatible. We'll specify the directory and again some parameters about the permission. Afterwards, we use the remote file keyword, followed by where to put the file and followed by where to download it from. Afterwards, we also can set permissions for the file that has been placed on our system. Next up, it looks a bit different. This is the dependency that we used to install Java. Instead of writing it ourselves, we can use this small function call to install Java. The file keyword can be used to create files at specific locations at the system and with specific permissions. For the second file, we create the minecraft.service file. This is used for systemd to make sure that the Minecraft server can run in the background. Next up, we use two commands to start and enable the Minecraft server on reboot. Note that when using the execute with the command, this will make the script only possible on operating systems that support this command. Before we can upload this cookbook to the Automate server, we need to specify our dependencies in our metadata. Sadly, the Burks file is only used by the Burks command line tool to upload and download dependencies. So this might feel as double work. We have to open the credentials file in the .chef folder. This has been generated by the knife configure command in the last section. And add the following line here to tell Chef where to find our cookbooks. Now edit the metadata.rb file and add the line depends Java. From this file our metadata is generated using the following command, knife cookbook metadata and the name of the cookbook, for our case Minecraft, which will create a JSON file where it specifies our dependencies. Now we're finally ready to upload our cookbook. Normally you can upload your cookbooks using the knife CLI. However, we have a few dependencies and the knife CLI doesn't know how to deal with those. Therefore, uploading multiple cookbooks to Chef Automate at once is easier done with the Burks CLI file. Inside the Minecraft cookbook directory, use Burks upload to upload all the cookbooks plus its dependencies. Lastly, to bootstrap a node with this new cookbook, use the familiar knife bootstrap command, append it with -r recipe, the name of the cookbook, : the name of the recipe. This will bootstrap and execute the recipe on the node. To check if everything is installed correctly, you could SSH into the server yourself, but the easier way is to do it with the InSpec part from Chef, which we'll get into the next section. For now, I'll head over to our Automate dashboard to show you that the run has been completed. So tune into the next section on how to work with Chef InSpec and get a good overview of your infrastructure. Welcome to the last part of the short tutorial series on Progress Chef. In this section, we'll talk about Chef InSpec and what it can automate for you. Chef InSpec is a tool to test your infrastructure nodes using a predefined set of criteria. For example, you can test if certain ports are open or if a service is running. These criteria are defined in Ruby files. Chef InSpec will read these files and execute the test one by one on your nodes. The status is then reported back to the Chef Automate server and visible on your dashboard. You can also use predefined compliance profiles from the Chef supermarket, like Linux Baseline, which will download the profile from the supermarket and execute the test inside of it on your nodes. To get started with Chef InSpec, let's open back up the Chef repository in Visual Studio Code. The Chef InSpec CLI should be installed with the workstation installation. To check if it's installed correctly for you, use inspec --version to see which version you're using. Inside the terminal, go to your Cookbooks directory. In our case, it's /Minecraft. To bootstrap an InSpec profile, run inspec init profile and then the name of the profile. And we're using test, and since there was already a test folder, we'll use --overwrite to overwrite the existing test folder. This will create a couple of files. For example, in the controls folder, we have an example RB file. In the controls folder is where all the tests will go. For now, we'll remove the example test file and create our own called default_spec.rb. Paste in the following content. In here, we are defining the title of the test and the control. The control is a wrapper for a set of tests. In this case, we'll give an impact of 1, which is critical. The higher the number, the higher the impact. After the describe keyword, we use systemd_service and we'll name of our service to indicate that we're looking for this service. And then we assert 3 things: that it should be installed, it should be enabled, and it should be currently running. And that is the actual test that will run on our nodes. We can test this test locally using inspec execute and the path to the RB file. As you can see, the test fails on my machine, since this machine is not running or has any Minecraft server installed. So it works. To get the InSpec profile onto our Chef Automate server, we will need to authenticate the InSpec CLI with the Automate server. For this we use InSpec Automate login with the URL of your specific Automate installation, and then -- user, specify the admin user. Again, we use the -- insecure because it has a self-signed certificate. Lastly, we'll need to get the token from our Automate server. For this, head on over to your Automate installation and go to the Settings tab. From here, click on API tokens and click on Create Token to add a token. We'll call this one InSpec and we'll give it all the roles. Then click on the 3 dots and copy the token, paste it between the quotes in the command. Once we have authenticated with the Automate server, we can use InSpec Automate Upload with the name of the InSpec profile. After uploading your InSpec profile to Automate, head on over to the settings and over to Node Credentials. Give the credentials a name, preferably the name of the node, then fill out the SSH credentials. Now head on over to the Compliance tab and click on Scan Jobs. Click on the other tab where it says Nodes. Click on Add Node and fill out the IP and the name of the node. Then select the credentials on the bottom and move them to the right. Then we're going to enable sudo mode, since our test needs sudo to run. To finish up, click on Add Node in the top right corner. Your node should now be visible here. Head on over to Scan Jobs and click on Create Scan Job. Here select Automate and click on Next. Select the InSpec profile that we have uploaded to the Automate server and click on Next. Give the scan job a name and you can add your schedule by checking the box Set Schedule. Here you can enter the start date, optional end date, and when it should repeat. For this tutorial, we'll uncheck the set schedule because we're just gonna run it once to get the results. So I'm gonna click on Save. Here you could now see that the status should be running or scheduled if you use the scheduler. After the tests are run, click on the report button on the right. Here you can now see the result of your test. Another advantage of using Chef InSpec is that you can use third-party InSpec profiles to test your infrastructure. To use these profiles, click on the Profile tab on the left and then click on the Available tab. Here you can search for Linux-baseline and click on the Get button. This profile will now show up when we create a new scan job. So let's head on over to the Scan Job tab and create another scan job. Follow the same instructions as last time, but this time select the Linux baseline instead of our own InSpec profile. Here again, I will not be using a schedule because I want the test to execute immediately. After the Linux baseline test completes, you can click on the report to see exactly what is going on. Under the Control tab, we can see exactly what we can improve in our infrastructure. I hope you enjoyed our short tutorial series on Progress Chef. We set up the Automate dashboard and we connected nodes to the Chef Infra server. The nodes are now showing up in the dashboard, which makes it easy to keep an overview of what's going on in your infrastructure. Furthermore, we use Chef InSpec to automate the compliancy checks on our infrastructure. We have now a dashboard where we can see exactly what's happening to our infrastructure. Last but not least, we have a dashboard overview where we can see what happened, when it happened, and who is responsible for the actions taken, which is helpful if you're managing your infrastructure with multiple people. Sadly, we didn't get into the Applications tab here. Here you can deploy and manage your applications running on the infrastructure. This will be a tutorial for another time, since this is another big part of the Chef ecosystem. See you next time.